Bonnes. Well, that's the way we say hello in Andorra. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt and I've come here to add some muscle to your mathematics. Today, we will be looking up trigonometric ratio. I'm sure you people must have studied in trigonometry trigonometric ratio. But do you know what is the definition of trigonometric ratio? I'm sure many won't be able to answer this question. For that, we huddle together and we will be trying to find out a proper definition of trigonometric ratio. Here, we will be looking up the 6 trigonometric ratios that you already know. Further, we will be looking up certain sums with these trigonometric ratios so that your concept becomes perfectly clear. We will also be looking up certain things which are really special about trigonometric ratios, and over that environment which is really icy, as I'm sure you people are able to see that I am at this special ski location in Andorra. This is Grand Valeria, a ski resort which is the largest in this country, Andorra. It has 128 slopes from the beginner level to challenger level. It has 210 kilometers of ski slopes. Make sure to be here, learn, and then enjoy. More about this place I will be telling you in times to come. But at the moment, let's quickly jump to studies and let's quickly look up what I want to tell you people about trigonometric ratios. So children, when we talk about trigonometric ratios, we actually talk about that we have some ratio, right? And I'm sure you people know that whenever we talk about ratio, we are actually interested in physical quantities of the same type which are divided. That too, their unit should be the same so that the units get cancelled and the resulting ratio doesn't have any unit. So one speciality that is there in a trigonometric ratio is, as it is a ratio, so it is going to be one which is not going to be having any unit. The second thing is, as it is a ratio, it will be from the set of real numbers. Like if you talk about a ratio which is 3/5 or say 13/7, all of these are from the set of rational numbers, and as they are from the set of rational numbers, they are also from the set of real numbers. So children, the first thing that I said to you people was, as we are talking about here a ratio, therefore we won't be talking about any unit, right? And the second thing that I told you people was that this is going to be a real number, right? More so here we will be looking it up as a rational number, because as it is a ratio, so we expect that there is going to be some numerator, there's going to be some denominator. But even if we have some irrational numbers which are there in the numerator or in the denominator, then too we are going to accept it is as a ratio, because we have different sort of physical quantities involved, right? Here, like we are interested in looking up distances, which are the lengths of the sides of a right angle triangle. So it can also be in the root form, so we are going to accept it. Okay, now the next thing is, what is a trigonometric ratio? Now, whenever we talk about a trigonometric ratio, the first thing that we want to know is there a right angle triangle which is available, right? Like I'm sure you people must have looked up in the shot that I told you that if we have a right angle triangle, only then we will be able to talk about the trigonometrical ratios, because in the trigonometric ratios we talk about the height, the or which can be said to be the perpendicular, then the base and the hypotenuse, right? So as we are interested in these three things, so we thus require a right angle triangle, because it is only there where it is possible. So let's say now that we have this XYZ, a right angle triangle, which is right angled at Y. Now the side which is in front of 90 is always the hypotenuse. It varies what is going to be the perpendicular. XY can be the perpendicular, or XY can even be the base. When it happens is what we're going to look up next now. So whenever you have a right angle triangle, then the side which is in front of the known or the unknown angle, in certain cases you know this angle, like it is 45 suppose, or in certain cases you got to find out what angle this is, right? So it is either the known or the unknown angle in front of which, if you talk about a side in the right angle triangle, that is your perpendicular, right? And if you talk about the side which is in front of 90 it is always the hypotenuse. And the third side, which is the one before the in front of this angle, the third angle is your base, right? Now children, if say we talk about changing the angle, now in place of talking about this angle which was theta, that is angle YZX, if suppose we are interested in talking about the angle alpha, which is the angle YXZ, then the side which is in front of it is going to now become the perpendicular, right? Which I'm now writing in small letters. The side which is in front of 90 that is always going to be your hypotenuse, and the third side which is in front of angle theta is going to be the base, right? So as such, whenever you talk about a right angle triangle, the perpendicular and the base, they can exchange their positions, but the hypotenuse is always going to be the largest side, that is the side which is opposite to the largest angle, the angle which is 90 So here we have a right angle triangle, and all of this I will just quickly discuss again, after which I will be discussing about what a trigonometric ratio is. So here children, we have a right angle triangle which is XYZ, and if we consider theta to be the known or the unknown angle in front of which we've got to find out the different sides, right? So considering this angle theta, the side which is in front of it becomes the perpendicular. The side which is in front of 90 is your hypotenuse always. And the third side, the one that you've not discussed, the angle which is in front of angle alpha, right, is going to become your base, right? And as theta is with red color, that's why perpendicular, hypotenuse and base have also been written in red color in capital letters. Next now, if we are interested in trigonometric ratios with the angle alpha, right, then we'll be talking about the angle alpha, right? So the side which is in front of angle alpha is now going to become the perpendicular, as I have written here in green ink, alpha as well as small letter p. Now the side which is in front of 90, as I told you, always is going to be your hypotenuse. So as such, your hypotenuse is xz, which has been written as small h. Then now we are interested in the third side, which obviously is in front of this angle theta, right? That is the side which is yet not been talked about. That is going to become the base, right? And thus we have our perpendicular, base and hypotenuse. Now comes what is a trigonometric ratio. Then we'll be looking up the 6 trigonometric ratios that you already know. So whenever we talk about a trigonometric ratio, it is a way by means of which we find out a relation between the sides and the angles of a triangle. Remember, when you talked about the definition of trigonometry, it was the study of measurement of the 3 sides of a triangle, right? So you had a figure which had 3 sides, that was a triangle, and its study was trigonometry. So like we discussed earlier, we had primarily 2 things to study. One was the angles which are there at the different vertices, and the second thing is the 3 sides, right? In times to come, we will be looking up more options which are available in this, but at this time for the basics, you should just know this, that primarily we are interested in finding out the sides and the angles of a triangle. And when we talk about a trigonometric ratio, that is one relation which develops a relation, or you can say that develops a sort of a form that the two things can be put together, right? The best word will be relation, right? So a trigonometric ratio is the way by means of which we make relation between the sides and the angles of a triangle, right? Now, the trigonometric ratios are thus got by finding out either sine, cos, tan, cot, sec, cosec of specific angles like of theta or of alpha, where on the other side we have a ratio of either perpendicular or base or hypotenuse, right? So either in the numerator or in the denominator we can just have perpendicular, base and hypotenuse, and that is going to be written to be equal to some trigonometric ratio, right? So the ideal definition that you can finally go for a trigonometric ratio is a relation between the sides and the angles of a triangle such that a trigonometric ratio like sine, cos, tan, cot, sec, cosec of an angle theta is equal to the ratio of two sides of a right angle triangle. The two sides being either a perpendicular or a hypotenuse or a base, right? So this is the exact definition of a trigonometric ratio. Now children, here one thing more I like to tell you people, that as this angle is 90, right, which is at the vertex y, or we can say that angle xyz is 90 degree, you require to remember the sum of the other two angles should also be 90, because sum of all the three angles of a triangle is 180, right? And as such the sum of these two angles is going to be 90, and as the sum of both of these angles is going to be 90, thus these are those angles that are complementary, or in other words you can say that alpha and theta are actually acute angles, right? So this is also, you require to remember that whenever we talk about the trigonometric ratios, we are actually trying to find out the trigonometric ratios of these angles which are either alpha or theta, which are actually acute angles. And in times to come you will get to see that these are the angles which fall in the first quadrant, and as such what happens is the trigonometric ratios of these angles will always come to be positive for any of the angles that you talk about. So what I'm wanting to say is, if say you talk about these to be the four quadrants of a circle, where here we have a circle, suppose say something like this, right? So let's say now here we have a circle, right? And this say is the center of the circle, and now if we talk about the four quadrants, we have here this to be a quadrant, this to be another quadrant, then we have this to be another quadrant, this is another quadrant, right? So these are the four quadrants that we have, and normally when we talk about the quadrants we consider this to be the first quadrant, right? And then we talk about this to be the second quadrant, right? And then we talk about this to be the third quadrant, and this to be the fourth quadrant, right? And do remember that whenever we talk about the first quadrant, in the first quadrant we have all the six trigonometric ratios, that is sine, cos, tan, cot, sec, cosec, to be positive. In the second quadrant, that means when the angles are from 90 to 180, right? For that matter, if you talk about here, we are starting from 0 degree, and whenever we move in the anti-clockwise direction, the angles are taken to be positive, right? If suppose we move in the clockwise direction, right, I'm sure you know the direction in which the needle of your clock moves, right? That direction is known as the clockwise direction, and if you take an angle in a clockwise direction, then that is going to be a negative angle. Now children, if you talk about the angles being taken in the positive direction, that is in the anti-clockwise direction, from here to here is actually 0 to 90 degree, which is your first quadrant. From 90 degree to 180 degree is your second quadrant, which is going to be for sine and for cosec to be positive, right? You require to remember this, that is for sine and for cosec you will have this to be positive. Rest of the four trigonometric ratios are going to be negative. Then after that you talk about the third quadrant, where you have tan and cot to be positive. That is when the angles are from 180 to 270 degrees, right? Tan and cot are positive, right? And now in the fourth quadrant you have cos and sec to be positive when the angles are from 270 to 0 degree, or you can even say 360 degrees, right? Because after one circle, angle about a point is 360 degrees. As such, here from 270 to 360 is the fourth quadrant, where cos and sec are going to be positive and the rest four trigonometric ratios are going to be negative, right? Now children, after knowing all of this being a little above your level, right, doesn't matter, knowing more is always good. We now quickly look up what the six trigonometric ratios are. The first is sine of angle theta, and we have it to be perpendicular divided by the hypotenuse. So if we talk about this angle to be theta, then this is the perpendicular and this is the hypotenuse. So if you talk about xy, which is divided by xz, then you will have sine of the angle theta, right? Now if you require to find out sine of the angle alpha, then obviously it would have been different, right? What would it have been? For perpendicular, for the angle alpha, we know that the side which is in front of it is the perpendicular, and thus it would have been the other perpendicular, that is the perpendicular that we wrote with small letters, right? That is the side yz. It would be divided by the hypotenuse. As you know that the hypotenuse will remain to be the same, so it will again be xz. So in the earlier case, children, it would have been perpendicular upon hypotenuse, that is, it would have been xy, which would have been divided by xz, right? But if you talk about alpha to be the angle, in that case then we will have this to be equal to the perpendicular being yz, that is to be divided by xz, right? So this is the difference in taking different angles for which sine, cosine, etc. are talked about. Now next we'll be talking about cos theta, which is also cosine of the angle theta. Cos being its abbreviation, it is based upon hypotenuse. So again here, as we're taking the angle theta, so the base we know is in capital letters, that is, it is yz, and it is going to be divided by the hypotenuse, which obviously is xz, right? And thus this is going to be cos theta. So just trying to write this once more so that you people can understand this. Rest four you all will have to write all on your own. So if you talk about the base here, we have it in capital letters, which is yz, and we'll divide it by the hypotenuse, which remains to be the same, that is xz. However, if we want to find out cos of the angle alpha, right, which is the other angle, you know that the base has become a little different. The base now has become xy, which here now is the third side. So further here again we will have it to be base upon hypotenuse in small letters, which were for the angle alpha, and further it is going to be equal to the base, which here is xy, right? And it is going to be divided by the hypotenuse, which again is going to remain to be the same, that is xz, right? So this is how for different angles in a right angle triangle we will have different values of cosine, right? Once if you talk about one of the acute angles, then for that the cos will be different, and for the other acute angle the cosine is going to be different, right? And this is how you're going to calculate it. Next, children, we talk about tangent, that is tan of angle theta, where tan is the abbreviation and that is equal to perpendicular upon base. Now to learn it, some people say a mnemonic, that is some people have curly brown hair turned permanently black, right? So this is how some people remember it, although if you write it twice or thrice, I'm sure you'll be able to remember this, right? Now the next is that if we talk about cot of angle theta, then you got to remember that this is actually the inverse of tan theta, right? And thus it is going to be the reciprocal ratio of what you wrote for tan, that is, it is 1 upon p upon b, or in other words it will become b upon p, right? Next after this, children, is sec theta, which is actually secant theta, like cot was actually cotangent, right? So now for sec theta we have secant theta. It is the reciprocal of cos theta. As such, 1 upon base upon hypotenuse becomes equal to hypotenuse upon base, which is the value of sec of angle theta. Now cosecant is abbreviated to be cosec of angle theta will be hypotenuse upon perpendicular, as it is the inverse of sine, and sine being perpendicular upon hypotenuse, it is going to become equal to hypotenuse upon perpendicular, right? So these are the 6 trigonometric ratios. Now after this we'll be discussing sums, but before that I will quickly be discussing all of this again with you people. But before that, one out a small joke. Okay, so if you talk about the people of Andorra, there is one joke which goes around that is said that people here wear slip-on shoes. Can you just reason? Well, I'll tell you. It is said that people wear slip-on shoes and not lace shoes, because in order to wear lace shoes you'll have to tie the laces, right? And for that you at least require an IQ which is 4 or more. All right, and this is the joke which goes around in Andorra and about the people of Andorra, right? Although I'm sure there must be pretty much intelligent people also. Now this place which I told you just now also has some special ski locations, right, where you will not just get to do ski, but they are actually theme ski parks, right? So again, that also becomes very interesting thing. So I'm sure you people should visit this place as soon as possible, because it is pretty cheap too, and you can visit with your whole family here. But remember to tell all the people there bonus. Okay, now quickly telling you people about trigonometric ratios. Now we know what a trigonometric ratio is, because we all know that we have sine theta, cos theta, tan theta, cot theta, sec theta, cosec theta, right? But what actually is the definition of a trigonometric ratio, or in other words, what does it mean when we say that this is a trigonometric ratio? For that matter, first thing that you should remember that it is a ratio, as such it is going to be the fraction where we'll be dividing two physical quantities of the same type and also of the same unit, right? As such, if you talk about the unit of the trigonometric ratio, it will be nothing. Or in other words, we can say that the trigonometric ratio is unitless, right? And the language of physics, we can further say that it is dimensionless. Okay, now next, children, when we talk about a trigonometric ratio, do remember it being a ratio is going to be from the set of real numbers, although we expect it to be a rational number, that is of the form of p upon q, where q is never equal to 0. P and q are from the set of integers. P and q always being co-prime. But that is not what we are going to get here. We can even get irrational numbers, but you do not require to rationalize them, as that is a trigonometric ratio. So that is its speciality. That is the value it carries with it. Okay, next now, what is a trigonometric ratio? So a trigonometric ratio is a relation between the sides and the angles of a triangle, such that in order to find out a trigonometric ratio of the form of sine, cos, tan, cot, sec, cosec, we of an angle, we divide some side of a right angle triangle with some other side of the right angle triangle. So one of the sides can be a perpendicular, or probably a base, or probably a hypotenuse. So next now, children, after this definition, we come to what can be the perpendicular and the base, because they keep rotating in accordance with the angle. So if we consider theta to be the angle, the side which is in front of it becomes the perpendicular, right? Now the side which is in front of 90 degrees always is the hypotenuse, and the third side is the base. Now if we consider this to be the angle alpha, which we are considering to be the known or the unknown angle, then the trigonometric ratios with it, like tan alpha, sec alpha, etc., will be such that in front of this angle alpha we will have our perpendicular. In front of 90 degree will always be the hypotenuse, and the third side is going to become the base, right? So thus you've seen that at some time for an angle, one side was a perpendicular, for the other angle it became the base, right? Now children, you also require to remember that whenever we talk about trigonometric ratios in a right angle triangle, as one of the angles is 90, the sum of the other two should also be 90. That means these two angles, theta and alpha, should be acute angles. So at this time, when we are talking about finding out the trigonometric ratios, we are finding out the trigonometric ratios of acute angles, right? And like I told you here, when we talk about trigonometry, we actually take up this circle, and its four quadrants are the places where we have different trigonometric ratios to be positive or negative. Now as the angles from 0 to 90 come in the first quadrant, as this being the reference line, the angles are measured in the anti-clockwise direction are positive. So we move in this direction. From 0 to 90, this becomes the first quadrant where all the trigonometric ratios for angles between 0 and 90 are always positive. So thus here, when we talk about sine, cos, tan, cot, sec, cosec, we will have it in the first quadrant, and they will all be positive. Now remember this, sine theta is perpendicular upon hypotenuse, cos theta is base upon hypotenuse, and tan theta is perpendicular upon base, which can also be said to be the ratio of sine of angle theta divided by cos of angle theta. And just try dividing both of these, right? And when you divide, then you will find that hypotenuse will get cancelled, as the fraction in the denominator will reciprocate, and you will have p upon h into h upon b, right? And thus you will get p upon b, which actually is tan theta, and thus tan theta can also be said to be sine theta upon cos theta. Now we have the reciprocals. So here I will try and make something so that you can remember this pretty easily. So what I'll do is I will make something like this. Like if you talk about sine, children, then remember that sine is going to be related with cosec, right? If you talk about sine, sine is going to be related with cosec, right? And they are mutually inverse of each other, right? Okay, so we have sine and cosec, which are related. Next then, children, we will be talking about the next, that is cos and sec are related, as they are the inverse of each other, and thus we will now mark it in a similar way. So now further we have cos, and then we talk about sec, right? Cos and sec are related, right? They can be said to be cousins, right? But they are such that they are inverse of each other. So here we have cos and sec, which are related, right? And the inverse of cos is sec, and similarly the inverse of sec is cos. Now finally we have the last two related, that is tan and cot, which are related in a similar way. So now we will mark it in the same way, that is, we will now talk about tan, right? And we will relate it with cot, right? So here further we now have cot, which is the inverse of tan, and tan, which is the inverse of cot. Now something very interesting is what I'm going to tell you next. You find that sine is the first and its inverse cosec is the last, right? Then you find that cos is the second and its inverse sec is the second last. Then you find that tan is the third and cot, its inverse, is the third last. As such, this order, if you remember, then you'll be able to remember their values as well. Okay, so do remember all of these as a formula. And one thing more, I showed you people that if you talk about sine of one of the acute angles, then their values will come to be different. However, as you know that with alpha, the perpendicular, the base will change. As such, with alpha, sine is going to become different, and similarly for all the other 6 trigonometric ratios, when you change the acute angle for which you want to find out sine, cos, tan, cot, sec, cosec, you will find that they will come out to be different for both the acute angles, right? So is all of this perfectly clear with you people? Sure? Okay, that's good. I'm sure you've been here till the end of this lecture. That's good, but there is more. But it is for those people who can now move on to the next part of the lecture by clicking on the link which is there in the description. So do click on the link which is there in the description of this lecture, and then you will be taken to a place where the rest of the lecture is. There is a lot of interesting things which is to happen, because I am going to discuss sums there of these type, right? And here further, to get all of this information, do click on the link and get to the other side and get this information, right? So that is all from my side. Bye.